Hi everybody. If you've watched any of my videos on visualizing four-dimensional hypercubes, you know you're at a disadvantage because I have this three-dimensional hypercube model that I can manipulate and observe, and you don't. You have to look at it through your 2D screen, and so you have to imagine the 3D model that I have. And then you have to imagine one extra dimension up to imagine 4 dimensions. Whereas I've got the 3D model, I only have one dimension extra to imagine. I just have to imagine one more dimension. So to help watch my videos, it'd be useful if you had one of these. And so in this video, I'm going to show you how to make one out of copper wire. And here's what we'll need. You need a working surface like your kitchen table. You need a piece of cardboard so that you don't damage the table. You'll need 72 inches. You need 6 feet of number 14 copper wire. Bare copper wire. And then get it reasonably straight. It's straighter the better, but it doesn't have to be perfect. You're going to need part of a yardstick. We won't measure a lot, so you don't need a full yardstick, but fully one would work too. You'll need a can of soup of some type. You'll need a pair of needle nose pliers, or regular pliers would work. You need a pencil and a felt tip marker or one of these kind of pens. And you need some electrical solder, that is for electronics where the rosin is, or the flux is right in the copper, in the solder. And you need a soldering iron or soldering gun. Now, the first thing you need to do is to lay out your wire and cut it into 9-inch lengths. So that would be 8 9-inch lengths. The 9 inches isn't too important, but the 8 is. We're going to get 8 of these. Now what I did is I laid mine out and marked it with this marker on the 9-inch. But while I'm at it, I also need to do half of that, so make a mark at 4.5, and then half of each one of those again. So that would be 2 1/4 and 6 3/4. The middle one is the only one that's critical. That needs to be right in the middle. These could be a little off. I mean, you could have this be at 2 inches, but then this one has to match it. So you have to have the same pattern of lengths for these two as you have for these two. And the reason is because they're going to fold up into parallelograms, and the opposite sides have to be equal. So you can do these, probably cut these as you mark them, and accumulate a pile of 8 straight wires like this. Okay, once you have your 8 wires, and then you have to have them marked, take your pliers and hold it just a little short of the, a little on the other side of your mark, and bend an obtuse angle. And the idea is that the mark should be exactly in the center of the angle. Not super critical, but the closer the better. You make an obtuse angle of probably 130 degrees or something like that. Then you go up to your next mark and bend that one. You sight along the plane of that V, because you've established a plane with that angle, and everything has to stay inside that plane. So you grip your wire and you pushing that wire so it's in line with the other one. And the idea is to get it parallel. So you push it until it looks parallel. Then you move around to the other mark, and you see that your plane, it wasn't quite exactly planar. With one eye you can sight. So what you do is you bend the wire until it is planar. Now I can see that all three of these segments are in one plane, and so you do the same trick. You sight through the plane and push this wire, keeping it in that plane. And the idea is to meet the other wire. And if you do, you should have a parallelogram. If you don't, your angles didn't get bent right in the middle, so you can adjust those a little bit. And I would recommend making these a little rough at first. I mean, not rough, but don't dwell on one of them right away. Just make 8 of these, and they should be parallelograms. Now, nice thing about corrugated cardboard is you have parallel lines in it, so you can just lay this down and see, are these guys parallel? Yeah, they look pretty parallel. And you lay these down. That's not quite parallel, but close. So you set to work and make 4 like this. Okay, now what you do is you take your best looking one, or the one you think is the closest to being a nice parallelogram. And incidentally, the quality of these things is strictly up to you. You can make them, they don't have to be perfect. But what I would do is take this one that you've made that's the best, and just trace around the inside on your piece of cardboard with your pencil. What we're going to do is just see how close the other ones are and bend them into the same shape. So we look at this one. So there's a couple things we're looking for. One is the same shape and the other is flat. They should be in the same plane, so they should lay flat on the cardboard. So this guy needs to be twisted a little bit to get flat. And it's very close to being the same shape. Incidentally, this is not critical to be the same shape, because as you know from perspective projection, lines that are farther away are shorter than the lines that are closer. And lines that are running away from you that are parallel really don't look parallel. So we don't have to be perfect. But perfect is better for this purpose. Then we look at this one. This guy needs to be straightened. Okay, now we do the same trick with more 9-inch lengths of wire, but we just bend, instead of this obtuse angle that we made to start with, make one that's obtuse but a little closer to being square, just for variety. And you'll be able to see the effect of these choices. You can choose whatever you want. So make 4 more with a little different angle. Okay, so now I have my 8 parallelograms, and I have 4 that are a little closer to being square. Now we start soldering them together. And the way we do that is we take, first of all I should tell you, in the structure we're going to make, in our Hypercube, these 4 squares, and these are squares even though the angles aren't square, just because it's a projection of squares out of a different dimension, and of course we can't keep all the angles to be 90 degrees because we don't have enough angles. But in the final product, all 4 of these are going to be parallel and or congruent, and there'll be something like this. Actually, there'll be something like this with this one on top. But these will all be parallel, So none of these will touch. They don't get soldered together. And the same with these. These are all going to be parallel to each other, oriented the same way, and none of those touch. So the only ones that touch are one fat one or one skinny one. So that's what we'll start with. And we have 2 more degrees of freedom to go. And here's what we'll use our ruler and our soup can. Okay, you set the soup can in the middle, that'll hold things. Hold that down, give us a little pressure so that we can... the idea is to make one corner touch like this. And the angles don't matter too much. But what we've done now is establish the 4 directions of our hypercube. Since a hypercube is 4-dimensional, we get 4 directions and no more. And these are the 4 directions that we have established. 2 that are parallel to the plane of the table, one running this way, running that way. And of course those are the same directions as the ones that are on the table. And then we have this direction and we have that direction. So that's 4 directions, that's all we get. Once we solder this together, we have established all of the angles in the whole thing. So we got 2 points touching there. We just heat up our soldering iron and wait till it gets hot. Now these don't have to touch. You can bridge the gap with solder. The idea is that we want to have those lines from different parallelograms parallel. Okay, there I got a nice blob of solder on there. Now we can remove the soup can. Ouch. Now, every other one of these has to be parallel to the ones that we've already established. So we've already got our whole hypercube, all the directions of it established here. So we just choose another one, and this one has to be, if we're going to solder to this fat square, we have to use one of these like this. And I think we'll do it this way, because so now we could use our cardboard to line up these to make sure they're parallel. Maybe that's the thing to do. We line this one up on the bottom parallel to the ridges of the cardboard. And then this one too. Now this can of soup was not the best choice because it'd be nice to have one that fit inside there. There. Okay, with a little jiggling and maybe some more cans of soup or whatever it takes to hold it steady, make these 2 bottom ones parallel, and you know you have to have a matching parallelogram on the other side. You have it clamped in so that it's 2.5 inch or 2 1/4 inches separated. It's parallel, and that these corners meet, and then you go ahead and solder that corner. The more of these corners we solder, the stabler the thing will get. Okay, let's have a look at that. Now it didn't come out quite parallel, but let's just see if we can't bend it to make it parallel. There. Okay, we need another one of these that's parallel to this one, a fat one. And this one has to go inside, has to go congruent to this one and parallel to it. So it has to go inside. That we open up this gap to pass through the wires, and we go inside, and for either one we just lay it on its side. No, we can't do it that way. We have to do it this way, because we have to have both of these outside ones touching the cardboard. We shove a ruler in there, set our can of soup on it, and then try to get this corner to line up. We need our soup can over here. Probably should have 2 cans of soup or heavier can. Okay, we have this corner all meeting. Okay, that doesn't take too long to set up. Now there's one other corner that we need to solder that's from that same operation, and it should be held together just by the structure. There it is, so we need to solder that one. Okay, got those 2 on there. Now I don't think there's any particular sequence you need to pick these. You just have to remember that all of these acute ones are parallel to these 2 acute ones that we already have in here, and they solder on to the other more obtuse ones. Now we need to figure out how to hook this one on parallel to the 2 that it matches, and let's hook it on to this outside wire. If we clamp this side and this side to the table, we'll have this joint up in the air. So the 2 sides we want to clamp to the table, we put under our yardstick, and we probably should have had 2 cans of soup. We adjust it until those 2 are touching, and then we heat up our soldering iron, solder that joint. Alright, let's take that apart, and there should be one more joint that we need to solder because of that new addition, and there it is right there. So we'll solder that one. Now I can see that we made a poor choice for angles, because the cube that's made of this one and this one is very flat, but that's okay. You can look at a cube and it'll appear very flat. So it's okay. It's just that it's nicer if you can get them all kind of evenly spaced, and most of them near cubic, like this one. Most of these are pretty close to 90 degrees. And here we're going to have one that's not close at all. Okay, let's choose another one. Let's choose one of these fat ones, because we can connect that to 3 points on this one. It has to be parallel to the one on the cardboard and this one here, and so it has to be up here. And we can see that we're not quite, these are not parallel, they're spread, so we'll bend what we can here to get them more parallel, more nearly parallel. Now that fits pretty well. So we plan on, let's do a strategy here on how we're going to solder it. We need to lay our ruler on one of these. Let's lay it on this one and this one. That is, put our ruler through those two so that it will hold up. Switch that over so you can see it. Okay, I'm making the bottoms match, and then I'm moving the soup can over to make the top match. And it's a little low, so I'm going to open this up. So it looks pretty good. Again, I'll solder that one. Okay, now we have two more joints with this piece, so we don't need anything to hold it. Let's just choose this one, get that joint to be pretty close. If I had a clean soldering iron, it would go up better, but I didn't do that. Okay, and the third joint up here is open a little bit, so we'll just bend it down so that it touches, and then go ahead and solder it. You see, the more we get of this structure, the easier it gets to solder them. A bit more rigidity. So we have two left to go. Let's choose one of these, which will be this more nearly square one. You find the ones that it has to be parallel to and congruent, and then keep it parallel and see where it's supposed to go. And so it goes these two inside ones and this this corner. So now this is what I was hoping to avoid, and we didn't avoid it. It was a bad choice that these two, this one and this one, are almost in the same plane, and so the wires touch or cross. and they don't quite, but they're too close. I mean, they're closer than I would like, but it works. So I'm going to they have to be squeezed a little bit. You got to make sure you get the things oriented right. So I see all three joints, all three corners touch nicely. So we need to pin it down. Let's pin it down with this side and this side, because those are both hanging out in space, and we can clamp our work so that the thing stands up. And we're going to be soldering this inside. Actually, we could solder either the inside or this outside. I think we'll do that outside corner first. Bend that down just a little bit to make them meet better. Okay. Now we have the inside and the outside, and they're both lined up pretty close to where they need to be. The outside needs to be bent down a little bit, so let's bend it until we So now we have this inside joint, and it's so we need a way to get our soldering iron in there. It'll come in from this side. Alright, one last square to put in here. And it's got to fit parallel to these guys, and it goes in just like this. So we need to choose two lines that are on the very outside of the figure for our ruler. So we can choose this line and this line and use those to fasten the thing down. Okay, I think we just have two joints left to go. This one, which is pretty close to being where it belongs. This one down here that has... Okay, let's do this one up here first. Alright, one joint left to go, and it's the one inside the middle there. Bend them all till they meet. And we're ready. Okay. Still hot, I'll pick it up with the pliers. But there you can see you have a four-dimensional Hypercube projected into three-dimensional space. So we have now a 3D model where we can imagine 4D cube, Hypercube. So I'll be making more videos on how to imagine 4 dimensions using this model. So if you can make one of those, that'll help you visualize what we're going to be talking about in the coming videos. So thanks for watching.